Now see here, Young's double slit experiment. So we are going to do here actually interference with the help of this experiment. Suppose we have got a source of light here which emits radiations or the light waves. So we can make the wavefront like this. This is the first one, second one, these are the wavefronts. And we know it, every particle on the wavefront acts as a new source of disturbances or the light according to Huygens principle. So now if I put a double slit over here like this is S1 and S2, then these two sources S1 and S2 are acting as coherent sources of light. Now the light will be emitted from here in this way, and we can write it is like this. So if you look at here, at this point crest of this source and crest of this source are meeting. Similarly, at this point trough of these two sources are meeting at a point. So on this line we will be getting everywhere the points where crest to crest and trough to trough are superimposing. And in this case, here intensity will be maximum. If I look at this point here, one crest and one trough, and similarly over here. So on this point and on this point, one crest and one trough is meeting here. So at this point intensity will be minimum, and here is the maximum intensity. So this one is here will be formed here the bright band here, and this one is a dark, and this one is also here a dark. So when the two light waves coming from two coherent sources superimpose on each other, we get a pattern on the screen where somewhere the bright bands and the dark bands are obtained. This pattern is known as interference pattern. So this whole thing is known as interference pattern. So see here, in a proper interference pattern, or you can see in a sustained interference pattern, bright bands are completely bright, and whereas the dark bands are completely dark, there is no light at all. So for obtaining the sustained interference pattern, we must take two coherent sources of light whose amplitudes are equal, and these sources are neither too large or nor too small. So now we have seen here the Young's double slit experiment. Now we have to study the relation between the intensity and amplitude and the phase angle. Similarly, we can take also in this way. If I have taken here the two sources in this manner, suppose you are taking this point, this is the source here S1 and this is the source here S2. Both are producing here the waves and they are coming like this. You can take, and they are meeting at this point. So these two sources have got, suppose, the different amplitude, and this one has got the different amplitude, they are superimposing. So now what will happen? So now we have to study this mathematical or analytical treatment of the interference pattern. So let us see. Suppose the displacement at any point of the light wave coming from source S1 is, suppose y1 is equal to a sin omega t. Omega is the angular frequency and t is the time, and a is the amplitude of the light waves coming from source 1. Similarly, we can write y2 is equal to b sin omega t plus phi. So the light coming from the source 2 has got the displacement at any time t is the y2, amplitude is b, and constant phase I have assumed between these two sources, that is the phi. So now this constant phase difference is here. Superimposition of these two waves will take place. So we can write y is equal to y1 plus y2. So when we write y is equal to y1 plus y2, that is a sin omega t plus b sin omega t plus phi. Now we can solve it and we can get to y is equal to a sin omega t plus b sin omega t cos phi plus b cos omega t sin phi. So now we can solve it here again. Here see here we can take here the a sin omega t, b sin omega t, cos phi, we can take here the sin omega t common. So we will be getting a plus b cos phi, and we can write sin omega t plus B sin phi cos omega t. So, these things we have here now the simplified here just by taking common. So, now we can solve it further here, we can simplify and we can take in this case let a plus b cos phi is equal to r cos theta, where r is the resultant amplitude and theta is the angle. So, this is the one component of the wave, and another one we can write b sin phi is equal to r sin theta. So, these are the two components I have taken here. So, now the resultant wave can be written here r cos theta sin omega t plus r sin theta cos omega t, and we can write here r into here sin omega t plus theta. So, this is the equation for the resultant wave obtained, but here after superposition actually, but now we have to solve basically these two equations. So, now we square these two equations and add them. When we square these two and add them, we can get r square cos square theta plus r square sin square theta is equal to a plus b cos phi whole square plus b sin phi whole square. So, now we can solve it. So, here it will be here r square is equal to a square plus b square cos square phi plus 2ab cos phi plus b square sin square phi. Now, we can write the simple form of these equations, and we will be getting r square is equal to a square plus, this is a b square cos square phi and sin square phi, that can be written b square plus 2ab cos phi. Now, in this case, see here we can write in terms of the intensity also. So, we can know it intensity is directly proportional to square of amplitude. So, obviously proportionality constant will be there. So, we can write I is equal to I1 plus I2 plus twice of under root of I1 under root of I2 cos phi. So, this is the resultant intensity at a point after superposition. I1 is the intensity of the light coming from the source 1, I2 is the intensity of the light coming from the source 2, and this cos phi is the actually phi is the phase difference between these two sources. Now, this term is known as actually interference term. If this term is available in the equation, it means interference is taking place. Suppose this term is missing, then intensity will be I is equal to I1 plus I2, and that is in case of the incoherent. So, whenever the interference is taking place, this equation is here. If the light sources are coherent, but if the sources are incoherent, then the intensity will be directly I is equal to I1 plus I2. So, we can write equation either in this form or in this form. So, these are about the interference and the expression for the resultant intensity. Now, we will discuss the conditions for constructive and destructive interferences.